expression that is x minus 1 over the cubed root of x minus 1. I might not want to rationalize the denominator at this point, but I might want to rewrite this using what I know about exponent laws so that I can come up with an equivalent expression. Because what I see when I look at this is that if I throw x equals to 1 into this equation, I'm going to have a 0 in the numerator and in the denominator, which I can't have. So I need to be able to write this as an equivalent expression, and you'll see why this is so important when we start to look at limits. So I can rewrite x as the cubed root of x cubed. So if I take the cubed root of x and I cube that, I'm going to get back to x. So I'm just going to rewrite it like that so that I can have a similar expression to something that I have in the denominator. And so what I end up having in the numerator is a difference of cubes. And I know from my work with algebra that the difference of cubes is the same as finding the difference of, or the cubed root of this expression. So it would be the cubed root of x minus the cubed root of 1 is 1 over, or it's multiplied by, the cubed root of x squared, and then I'm going to have plus the cubed root of x plus 1. So I'm just multiplying 1 times what the cubed root of this would be, which is the cubed root of x, and then 1 squared is 1, or negative 1 times 1 times 1 is 1. Okay, so that's what I have there in the numerator. So that's my difference of cubed formula. And then the denominator, I'm going to have the cubed root of x minus 1. And what I see now is that I have this cubed root of x minus 1 expression in the numerator and in the denominator. So I am just left with my cubed root of x squared plus the cubed root of x plus 1 as my expression. So I no longer have a fraction, and I still know that x can't be positive 1. Taking a look at this next expression, again, I want to think about what is an equivalent expression that I can have here. Now, I have a difference of powers to the root 4 here. And I know from, again, my work with algebra, that this is going to be the 4th root of x to the exponent 4, which is x, the 4th root of 1, which is minus 1. I'm going to times this by x plus 1, because that's also part of that. And then I'm going to do x squared plus 1 squared is 1. So I know that this is the difference of quads, I guess, if you want to say that. And then the denominator, I have a difference of cubes. So I'm going to have x minus 1, and then I'm going to have x squared plus x plus 1. So I can see right away I have this x minus 1 term that's common in both the numerator and the denominator. So I am left with x plus 1 times x squared plus 1 over x squared plus x plus 1. Now I also have a difference or a sum of squares here, but there's nothing really I can do with that. So I'm just going to keep this like this. I mean, if I wanted to, I could factor this, but it's not going to work out nicely. So I'm just going to keep it like this, and I need to think about what are my restrictions. Well, I know that x can't be positive 1, because if it's positive 1, then my denominator is going to be 0, and then everything else is fine.